All right, Algebra 2. Welcome back. 6.3, fancy word, logarithms and logarithmic functions. So, Lavisa, you're probably smiling right now. We finally made it. Finally got there. We'll touch base on this a little bit. We'll get covered, introduced, and if those of you, some of you are taking college algebra next year, just hook me up if you have questions with this next year as it gets, we'll get into more involved stuff. But that word right there, logarithms. Logarithms are basically the inverse of an exponential function. So we have inverse operations that go on in mathematics. Inverse of addition is subtraction, multiplication, division, squaring, square rooting. Those are inverse operations. If you have an exponential function like y equals 2 to the x, you can have an inverse function to that, and it's called a logarithmic function. So logarithms will undo exponential functions. So logarithms will undo exponentials. So if you have something like x squared, you could do the square root of x. That's going to undo that one. But if you have 2 to the x, you can't take the x root of 2 to the x because you don't know what x is. So that's where logarithms will come into play. Okay, so for every exponential function of the form f of x equals b to the x, you could also say y equals b to the x. It has an inverse function that you can denote by g of x equals log base b of x. So it'd be y equals log base b of x. So this inverse function is called the logarithmic function with base b. So in these examples here, this is what you're going to see a lot of in just practicing this. You have 2 to the x equals 8. So this is kind of like the y value. Now remember, in inverse functions, if you have an x and a y for a function, the inverse will have a y and an x, a yx in that order. So this is an exponential equation. The logarithmic equation would say, okay, I'm going to take the log, I'm going to have a base of 2, because your base is 2, of 8, and then that's going to equal the x. Because now you're solved for x. Log base 2 of 8 equals x. Log base 2 of 8 equals x. So that's read log base 2 of 8 is or equals x. Okay, so write these down. This would be log. Our base is 3 of the answer, 9, because remember, the answer becomes the question becomes the answer when you're doing inverses, equals x. So log base 3 of 9 equals x. Okay, you know what that is? So 3 to what power is 9? Well, that would equal 2 in this case. This one would equal 3. So log base 2 of 8 is 3. Log base 3 of 9 is 2 because 3 squared equals 9. Okay. Log base 4 of 2 equals x. That one is a little bit trickier. 4 to what power is 2? 4 to what power is 2? Well, that's the square root of 4 is 2, so that'd be the 1/2 power. So 4 to the 1/2 power is 2. That's the square root of 4. 5 to the x equals 1. So log base 5 of 1 equals x. So 5 to what power is 1? And everyone says together, 0. Anything to the 0 power equals 1. Woohoo, we remembered, right? 5 to the x equals 1/5. So log base 5 of 1/5 equals x. So this is a fraction. X has to equal -1. It's a reciprocal. X 5 to the -1 equals 1/5. You see, getting the hang of this? Ooh, this would be a tricky one. Log base 8 of 4 equals x. I'll just tell you, that is going to be 2/3 power. Okay, 8 to the 2/3. It's the cube root of 8 squared equals 4. Okay. So that conversion from exponential to logarithmic, that's part of what you'll see. A lot of the graphs, you won't have to deal with graphs, I believe, on your assignment. I should double check that. Okay, rewriting in exponential form, rewrite in logarithmic form. Your logarithms, you will need to go basic. Okay, how do you type a logarithm here? So log maybe you need to do this base 12 of 1 equals 0. That'd be my guess. That's how you do it. So you type in log, L-O-G, then you're going to use this to get your base number. I don't see any other log button on here. So try that. If that's not working, let me know. We'll figure something else out because there's no other menu to use here. Okay. Oh, no. Okay. I'll let that load again. I'll see what other questions we have. Get back to this. So there's your terminology. Please fill this in. Logarithm of y with base b function. Common logarithm. A common logarithm has a base of 10. So you use 10 when no other base is written. Use 10 when no other base is written. So if you say log base 2 of 4, that's going to be log base 2. So 2 to what power is 4? 2 to what power is 4? And we're going to say 2. But if they just say, okay, what's the log of 20? This would be a common logarithm, which means 10 to what power is 20, which is going to be some weird number. Okay? So that's a common logarithm. Natural logarithm is the L with the N, and the base is E. The base is E. So on your calculators, you'll see those two logarithms. Right here, you see the log. That is a common logarithm. The ln is a natural logarithm. So if I do a common logarithm of 100, I'm going to get 2 because 10 to the second power is 100. If I do 1,000, that'll be 3 because 10 to the third power is 1,000. If I do a natural logarithm, okay, that's going to be base E. So these are going to be weird numbers that you get. Now I can do the natural logarithm of e to the first, and I'm going to get 1 that way. Okay, so natural logarithm is base E. Common logarithm is base 10 unless it's told otherwise. Okay, so there's your definition of logarithms. Log base b of y equals x. If and only if b to the x equals y. So let's say I have log base 10 of 100 equals 2. So if I want to write that in exponential form, I have to say 10 to the second power equals 100. So the base to the answer equals the value. So the base to the answer equals the value. If we're going the other way, 5 to the third equals 125. You have to take the log of the base. Now here's where the answer goes, and that's going to equal your exponent. So log of 5, log base 5 of 125 equals 3. So this is kind of your formulas going back and forth from logarithmic form, exponential form. Stop and go back and listen to that again if that went too fast. Oh, there we go. There we go. So log base 5 of 125 equals 3. Log base 5 of 125 equals 3. So that's your base. That's your exponent. Okay, there's your answer. Okay. So your graphs, you won't see a lot of these, or any of them, I don't think, actually. You got calculator work also. Okay. So remember, these are inverses. So if 0, 1 is on the exponential graph, 1, 0 is going to be on the logarithmic graph. They are reflections of each other over the identity function, which is the y equals x. If I have a point up here, x, y, that means this point right here has to be yx. Okay. The domain is x is greater than 0, and the range is all real numbers. Okay, so rewrite the equation in exponential form. So log base 10 to 1,000 equals 3. We've done this already. This is our base. 10 to the third equals, there's your exponent, 1,000. 10 to the third equals 1,000. Okay, number 2, your base is 5. Your exponent is -2, and your answer is 125 of your value. So 5 to the -2nd is 125. Okay, stop this. Go get the next 2 written down, and come back and check. So 10 to the 0 power equals 1. 10 to the 0 power equals 1. You can check that on a calculator. 10 to the 0 is 1. 1/4 to the -3rd equals 64. You don't have to do any calculating. You just need to know how to convert those. Okay, going the other way, rewrite them in logarithmic form. Okay, so 12 squared equals 144. So log base 12 of 144 equals 2. Okay, log base. There's your answer, and this is what it's going to equal. So log base 20 of 1/20th equals -1. Log base 216 of 6 is 1/3, and log base 4 of 1 equals 0. Okay. So evaluating the logarithms, the only thing you'll need to do is use your calculator. You can use these. Some of these are kind of fun to do in your head. I know some of you won't like to do that though. So let's just use your calculator. Now remember, if you hit log button, that's a common log. So they have what they call the change of base formula. And there's some of your calculators will probably have it in there and let you adjust what you're doing. This one doesn't. So if I hit log, remember that is a common log, but there's a formula that says, okay, if I have a different base, I can take the common log of 64 divided by the log of 4, and I'm going to get my answer. So if your base is not 10, this is what you do. Log of 64 divided by log of 4. Typing it in, make sure you close your parentheses. Log of 64 divided by the log of 4, that is 3, because 4 to the 3rd power is 64. That should equal 3. 4 to the 3rd power is 64. Okay, so mentally, 1/8 to what power equals 1? Well, hopefully you remember a rule, but if not, you're going to take the log of 1 divided by the log of 1/8. So log of 1 divided by the log of 1/8 is 0. So yes, 1/8 to the 0 power. Anything to the 0 power is 1. 2 raised to what power is 1/32? That's going to be -5. Okay, so you do log of 1/32 over the log of 2, and you get -5. So 1/25 raised to what power is 1/5? Ooh, that's a tricky one. That's just going to be a half. Okay, so we're going to do the log of 1/5 divided by the log of 1/25. Oops, I need that extra parenthesis. And we get 1/2. Okay, and that's pretty much what you need. We're not doing any of the finding or the graphing or anything like that. Just evaluating. There's a word problem where you just have to plug in a number to a formula. And then just a lot of calculations. You have some of these. Evaluate that using a calculator. Notice it's a common log. Just use your common log button. And that's a natural log. So be careful, that's a natural log. Use the ln. That's a common log. Use the log. So use the right buttons there and you should be fine. So good luck. This is really strange teaching to an empty classroom. I think I'm starting to feel more comfortable, but miss seeing you in here, miss the interaction, hearing about your stories and how you're doing. So let me know if there's anything I can help you with. Talk to you later, kids.